Right, welcome to this video on simultaneous equations. We're going to solve a couple of pairs of equations, and this is the first one that we want to have a look at. And the idea with simultaneous equations is that you have two letters. You have an x and a y, and you have two equations. If you just had one equation and you had an x and a y, you wouldn't be able to solve it because this value would depend on this one and this one would depend on that one, so there would be an infinite number of pairs as possible solutions. So that's why they need to give you two equations whenever they give you two different letters. So what's useful here, this example is quite simple because we are lucky in that this 2y has an exactly the same amount down here also of 2y. So what you can do with equations is that you can add them and subtract them together, which is a bit of a strange idea, but you can add the two sides of an equation or you can subtract the two sides of an equation. So for example, I can add this side of this equation to this one, and if I do that on the left and I write down the answer on the left, I'm going to have to do exactly the same with the right. So I've got to add this side to that side. As long as I do the same thing to both sides, I'm going to be fine. So the key here to decide is first, am I going to add them or am I going to subtract them? And what you should guide your own answer by is by the signs of them. Here you have plus 2y and here you have minus 2y. Because the signs are opposite, you want to add them. How do I know I want to add them? Well, you're starting with plus 2, right? Plus 2y. And you have here a minus 2. Okay? And plus 2, if I have a plus 2 here and I add minus 2, what's going to happen is that plus and a minus, when they're close together like this, is the same thing as a minus. So what I have here is then plus 2 minus 2. And that's going to give me 0. Why do I want a 0? Because I'm trying to get rid of one of the two letters. So if I add these two in such a way that they give me 0, then I'm only going to have an equation only with x's, which means I can solve the equation for the x, and then later I can do it for the y. I'll show you how to do that. But hopefully it makes sense to you that when they have different signs, you have to add the equations. Okay? And when you have the same sign, imagine that this was a plus, then plus 2y, if I have another 2y here, then I need to subtract the 2, and that way they would cancel, right? But that's not the situation we have. We have different sides, so we're going to add. And the rest is simple. How do you add 3x plus 5x? You just get 8x plus 2y plus minus 2y. It's the same thing as plus 2y minus 2y, and they disappear, they give you 0. So I don't have to write anything down. And here 21 plus 19. So that's nearly 20. So 21 plus 20 would be 41. But it's one less, so it's going to be 40. So now I have 8x equals 40, and now I know that I want to get rid of the 8 here in the equation. I do that by dividing both sides by 8, such that I get an x over here, and here I get 40 over 8, which is 5. So I've got half of my answer now. How do you get the answer to the other half, to the y? Because we still don't know what y is. Well, you can now choose whichever equation you fancy, whichever looks nicer, this one or that one, and you can write down the equation knowing that x is 5. So let's write the second equation. 5x minus 2y equals 19. So I can use this to find y. If I know that x is 5, then 5x is 5 times 5 minus 2y equals 19. And now I can move around things to find out the answer. Let's move the 25 to the other side. Okay. So actually I'm going to move the 2y first, because that's going to be a little bit less confusing, I think. So if we move the 2y, minus 2y, I want to move it. What do I have to do? I have to add 2y to both sides. So if I add 2y to both sides, here I get 25 and the 2y's cancel. They add up to 0. And here I'm adding 2y's, so it appears as plus. Now what do I want to move next? The 19, because I want to leave the y alone. So it's adding the 19, so I want to remove 19 from both sides. 25 minus 19 is 6, and here I'm left with just the 2y because the 19 disappeared. And finally I want to move the 2, it's multiplying, so I want to divide by 2, so I get y is equal to 3. So now I've got my two answers, x is 5, y is 3, and I finished. To check that it's right, go to the other equation, the one that you didn't choose, and see if it makes sense. 3 times 5, 15, plus 2 times 3 is 6. 15 plus 6, 21, so we've done it correctly. Okay, so we're going to do another example where the solution is not to add but to subtract. So let's see, imagine that we had something like 7x and minus 2y equals 8, and 7x plus 6y equals 32. And so we look at these two simultaneous equations and we say, okay, this 7x and that 7x are the same, and they both have exactly the same sign. So what's the solution? Well, before they had different signs, so we added, so now they have the same sign, so we're going to subtract. What happens if we subtract 7x minus 7x? We get a big fat 0. We don't need it, we can just omit it. Minus 2 minus plus 6y. Okay, so we're going to do minus 2y minus positive 6y. Minus and a plus, when they're closer together like this, it means minus. So this is the same thing as minus 2y minus 6y. Okay, and if I'm in my number line, this is 0, and I'm on minus 2, which is this, and I subtract another 6y, I'm going to go subtract another 6, I'm going to get even further away from the 0, I'm going to end up on minus 8y. So I go back up here and I say minus 2 minus 6y is minus 8y. 8 minus 32, well, 32 minus 8 is 24, and so that's going to be minus 24. Now look what happens, I've got a minus on the one side and I've got a minus on the other, so we can use a little trick, which is to do the same thing to both sides. What can I do to this side to get rid of the minus, and this side to get rid of the minus? Well, you multiply both sides by this magic number called minus 1, because if you multiply anything by minus 1, it becomes positive, or it becomes the opposite sign. So here, minus 8y times minus 1, you're going to get positive 8y, and here minus 24 by minus 1, you're going to get positive 24. So now divide by 8 both sides and you get your answer for y. We still need the answer for x, so the trick there was to go up here to one of the two equations and to use it. So let's use this one. And we want to find what x is, so we write 7x minus 2y equals 8, but we know that y is 3, so 2 times 3 is 6, and that's equal to 8. So now we need to solve this guy, and you should know how to do that already. You move the 6, which is the farthest away from the x. To do that you have to add 6 to both sides because it's subtracting, so on this side it disappears. On this side you add 6, you get 14. 7 times something is 14, and you already know without doing any fancy algebra that something is 2. So you have your two answers by dividing 7 by both sides, and you can now come up here and choose the other equation, the one that you didn't choose before, and you check if it's true. According to us, x is 2 and y is 3. So 7 times 2 is, I'm running out of space here, 7, I'm going to do it up here, 7 times 2 is 14, plus 6 times y is 18. So 14 plus 18 should be equal to 32, and if you try that on your calculator or on your head slowly, it will come out to be like that, so we've done it correctly. Okay, so this is called the subtraction or the addition of equations method. So you're actually adding or subtracting whole equations to cancel out one of the two things. Okay, and this method is especially easy when you have a 2y and a 2y, so you have the same number of letters on the top and the bottom. Or here we had the same situation, but instead of the y's we had the x's to be the same. In some cases you don't have the same number on either one of those two, and in that case you have to manipulate one of the two equations in order to get it to be the same, and we'll do that in a future video. Bye for now, thanks for watching.